So we talk about the material sensitive, we talk about the structure sensitive, we talk about the climate sensitive, then let us talk about the activity sensitive construction. The activity sensitive construction, let us first call about the in Jammu Kashmir, the Dhajji and Dhauri. See, this particular Dhajji Dhauri construction is a vernacular construction. No engineers has been intervening in that. Probably last 10 years or so after this particular, not 10, 20 years or so after this earthquake is become a very mega kind of event, we go and see what is that. This particular type of construction, if you see, it is the wood and the stone mixed construction. The wall panels are made up by the diagonality of the wood, and those triangular open spaces is filled with the stones, larger stones and the smaller stones. This machinery is called Dhajji Dhauri, and this is the one of the best machinery has been seen to protect from the seismic activity. The thing is that when the diagonals are made by the wood is one of the material which absorb lot of shock absorber. It acts as a shock absorber, and a diagonal pattern will actually behave a better shock absorber because diagonal pattern you have to give, because I do not know from which direction the earthquake will come. Earthquake may come, I mean, it's depend upon where is the epicenter and where is all those. So it may come like this, it may come like this, or it may not be in the orthogonal direction of the building, it may come like this. So you need the multiple line of defense. So in a panel, a multiple line of defense may be created by at least by the diagonals or maybe further bifurcation of those diagonals. So this particular these diagonals, wooden diagonals will be the actual act as a shock absorber, and then it will be filled with the stones, and it is a dry machinery. So you may say that the dry machinery will be prone to collapse, right? Which we have seen in the Himachal building. But it is a full, from bottom to top, it is full dry machinery. So if you shake it, it will going to collapse. But here what will going to happen? It is actually embedded or encircled by a triangular or some small pieces. So after kind of a shaking or after some kind of a vibration, first of all this dry machinery will rearrange itself. By virtue of the rearrange, some of the energy is absorbed. And even though it fell will be locally. It will be fell by virtue of this triangular part only. The triangular part of the failure will not lead to the failure of the next neighboring triangle. If next neighboring triangle has that much of scope and the orientation of the stones are in a different way, so it is not going to give you a progressive collapse. It may give you a local collapse. It may give you a small damages, definitely damages, but that damages will be arrested in a bounded by the wooden. How intelligently they have described this particular, constructed this particular building, which actually lead to some kind of the understanding of this particular thing is that how to stop the progressive collapse of the building in time of earthquake, which is very much essential nowadays. A multi-storied building may collapse. In Ahmedabad we have seen, a multi-storied building is been collapsed because of the damage of 3 or 4 pillars. And total building may have 40 pillars. Out of that 3 pillars, damage is actually devastating. It's a progressive collapse of the building. So what we have to learn from there? I do not know the solutions, but from this we should actually think of how to arrest the progressive collapse, and we actually manage the local collapse or by local damage. So I have written down the mortar machinery in fields also that we have discussed. The next one is another part. If you see the Andaman and Nicobar Islands, the traditional houses of the Andaman Nicobar Islands. Andaman houses are conical and something like that. And the Nicobar Islands houses are something like this. Ongo. This is Car Nicobar house. Sorry. And this is the Onge house of the Andaman, little Andaman. Thatched, mud, bamboo. It is some wooden pillars. So very interesting. Then number 1 is the shape of the building is either conical, circular, spherical, conical, like that. These houses are little bit lifted. We do flood prone areas and all, we lift our house. Why circular? Circular is important because in time of cyclone, it is this particular area is prone to cyclone. Any cyclone you see, it started in the, so cyclone, when there is a thrust of air, I mean when the air is blowing, if the air is blowing in a perfectly this kind of rectangular shape kind of a thing, it's actually give you the P into area, the area force, the intensity and into the area is full area, so intensity into area. But if there is a wind, the intensity comes, the area is only this strip area, other areas are tangential. So when the things will come, the effect of the force will be actually evaluated by virtue of the strip area and the intensity. So the other part, the wind will going to actually slip. So the total amount of thrust accumulated in a building will be much smaller with respect to a rectangular building or any kind of straight edge building. So we know this, we have some kind of a coefficient, I forget the coefficient for square housing, square building, that is the draft, I think draft coefficient or whatever, which is very high, this is very low, this is circular building is very less. So this, then that is why the cyclone shelters in Odisha, which is made now, we made it some circular kind of a edge instead of going with a perfect this kind of edge, making kind of a circular, that thing should be laminar, the flow should be laminar. But what those fluid mechanics, how they know the fluid mechanics so better in these particular buildings? In this particular buildings also, it is a very good noticeable thing is that you see the base is very large, the base of the building is very large, the height of the building is smaller. That means it is something like spreading the legs like this, and this is very stable. As and when you spread your legs and reduce your height, your center of gravity of the building will be very low. And as and when the center of building gravity of the building is very low, it is very difficult to topple you. It is very easy to topple me because my center of gravity is here. I am a tall man. But a small and a hard-built man, it is very difficult to topple because the center of gravity is low. So see the pattern of the building, circular and the, so this center of gravity, this fluid mechanics and all we know, but this is vernacular architecture where maybe definitely there is failures in their lives also. When they construct, there are some failures, they watch the failures, they rebuild their house in a different way and finally come down to some kind of a conclusions. I think that's all from my side. I have addressed the 4 type of the construction type of technology of thinking.